Chapter 16, logically, the next chapter in this journey we have. So we've just finished talking about ionic and metallic bonding in class, and now we're going to talk about the other major type of bonding, which is covalent bonding. So a little bit of review, as you can see, we have from above the line. So I want you guys to write down what happens with electrons in an ionic bond. We've really been focusing on that. You just finished a double period with me, essentially dealing with that very issue, so you should be able to write in something there. It's part of your homework to do that. Covalent, on the other hand, means that electrons are shared. But you got to think about compounds where sharing is going to be the only way that elements are going to be willing to interact with electrons. So what kinds of compounds would have that kind of a bond? What kind of metal-non-metal combination would you expect? For that, I want you actually to write down what you think. And I want you to do it now, even though we might indicate what the answer is a little bit later, just to see how your first guess is. So take a moment and do that. Okay, so let's talk a little bit about molecules and molecular compounds, and we're going to eventually start bringing dot structures back into this, but for today, in this video, I want you to focus on, we're going to do some properties work. So a little bit of review. Ionic compounds usually are what state of matter at room temperature? Well, they're usually solids. And so for that reason, you should be able to say something based on that. Most ionic compounds, therefore, must have a high blank. That's, again, part of your homework is to fill that out. They're usually solids room temperature, so that should give you a hint as to what you should be writing down. Some compounds out there, though, have very different properties than ionic compounds. And they don't follow this rule. Like some examples might be some things that aren't solids at room temperature, things like water or carbon dioxide. Or everybody's oxygen. Okay, these are all covalent compounds, and you could even throw a couple more in there if you want. They have very different properties than ionic compounds. And we talked about the opposites attract, is on page 2 now. Talk about the opposites attract ionic bond last chapter. You know, the positive, the cations attract the anions, and that's the nature of that bond. Do you think the same principle applies for these different kinds of compounds? I'm kind of leading you to the answer. The answer is no. Okay, it's because the electrons are really being held very tightly by these nonmetals. You don't have an opposites attract situation. So instead, the atoms are not really as piggy. They don't really go after each other for electrons so much. Instead, they have to share. So that's the biggest difference, is that they share electrons. That's very nice. I know, very sweet. The bonds between these atoms are called, well, I mean, that's the whole point of the chapter. They're called covalent bonds. Okay, so these are bonds where the electrons are shared instead of transferred. So let's talk a little bit more about the properties. Molecular or covalent compounds are quite different from ionic compounds. Many are blank at room temperature. They exist as blank, where ionic compounds exist as blank. Let's see, many are, well, let's see, we've got, that's a liquid at room temperature, that's a gas, and you can probably come up with a couple solids too, but their point is that unlike ionic compounds, you have all different states of matter. Well, it's liquids or gases at room temperature. They exist as individual molecules. Ionic compounds don't. Remember what ionic compounds exist as? We actually had a name for them. And I want you to write that down. Ionic compounds don't exist as individual molecules. If you have salt, like NaCl, it's not just an NaCl molecule. It's something else I want you to write down. That's part of your homework. And so based on the fact that many are solids, liquids, or gases at room temperature, the melting and boiling points of molecular compounds tend to be blank than ionic compounds. Again, I think you should be able to fill that out. So that's up to you. Now, there is, we have to talk a little bit about molecular formulas, which literally is the formula of the molecule. But because they exist as single molecules, the molecular formula, instead of just telling you the ratio, like NaCl means that there's a 1-to-1 ratio, but as you guys know, it's like billion to a billion. You know, it's many, many, many atoms and ions. But as opposed to the ionic compounds, because these guys exist as single molecules, the molecular formula tells you exactly how many atoms of each element exist in one molecule. There we go. Oh, the formula may, because of this, it may be reducible, but it's still the molecular formula, and you have to leave it alone. For that, I want you to write glucose's molecular formula down, which, as I'm sure everybody knows, is C6H12O6. And this thing is like begging to be reduced, but it doesn't get reduced. Doesn't get reduced. And that's because that is the number of carbons, hydrogens, and oxygens in a molecule of glucose. And that is not the case for NaCl, which has billions and billions of each. These are individual molecules. This is why I never let you reduce things in polyatomic ions. It's because they're covalently bound. And so those are actually the molecular formulas. Write down oxygen's formula, and then write down some other covalent compounds you know over here on page 3, and you'll see that some of them have reduced, but some of them don't have reduced formulas, and that's okay, because sometimes, like H2O, for instance, it's 2-to-1. That's just how many atoms there are in each molecule. And so it just happens to be a fully reduced form, but it doesn't have to be. Like in the case of glucose, it's not. In the case of oxygen, it's not. See if you can come up with a couple other compounds that maybe do or don't have reducible formulas, but you won't touch them, because when you have a single molecule, that's what you have to stick with. So that's all I wanted to share with you this weekend. I hope that it's a good weekend for you, and I'll see you guys on Monday.